All right, the last thing for this section is we're going to be working with imaginary numbers. So imaginary numbers and consequently their conjugate pairs, like we talked about in the previous section, can also be advantageous when we're trying to factor things down, factoring out polynomials. Remember, conjugate pairs, if you have something in the form a plus bi, its conjugate is a minus bi. So we're asked to find all the zeros of f of x equals x to the fourth minus 5x to the third plus 10x to the second minus 20x plus 24, given that 2i is a zero. So one hint is that multiplying 2i by its conjugate pair is going to help you get a real factor. Now I'm going to move the image on the screen so that way I can keep writing at the bottom. There we go. So we're told that one of our zeros is x equals 2i. Now, based on what we know, x equals negative 2i also has to be a zero. There's no way you can factor something down and get just positive 2i. Like when we've done it in the past, say for example, if you had x squared plus 4 equals 0, when we factored that out, we subtracted, or when we solved it out, we subtracted 4 and we get x squared equals negative 4, and then we take the square root of both sides, and we get x equals plus or minus 2i. So we have to have a positive and a negative 2i. Now, for the positive 2i, the factor equivalent would be x minus 2i. For x equals 2i, the factor equivalent would be for x equals negative 2i, I'm having a hard time speaking right now, it'd be x plus 2i. Now, what we're going to do is we're going to take these two polynomials, these two binomials, and multiply them out. We have x times x, which is x squared, x times 2i, but also negative 2i times x. Well, x times 2i is 2ix, and then we also are going to get negative 2ix. So those are going to cancel out. Let me write that out a second. So we got plus 2ix minus 2ix. Those are going to cancel out, just adding that visual. Now we're also going to have negative 2i times positive 2i, which gives us negative 4i squared. Consolidating down that down to just one line, we got x squared minus 4i squared. I'm getting a little ahead of myself. Now, quick reminder, the other day we talked about I squared by definition is negative 1, because if I is the square root of negative 1, we square it and we get negative 1. So that really, x squared minus 4i squared really is x squared plus 4. So we're going to treat this as a factor. Now we're going to use that and factor it out of that original polynomial. So again, our factor being x squared plus 4. Now, unfortunately, we're not going to be able to use synthetic division. Even though it's a nice binomial, it's not a linear binomial, so we can't use synthetic division. So we're going to have to do long division, and you know what? We'll be okay. So the original function, we have x to the fourth minus 5x to the third plus 10x squared minus 20x plus 24. And we're dividing that by x squared plus 4. Now, if it helps you, if you want to include that 0x, that missing term, that might be helpful as you're doing this. So we're going to go through piece by piece, again, primarily focusing on the x squared. How do we get to the biggest remaining term? X squared times what gives us x to the fourth? That's x squared. So we're going to multiply this whole thing by x squared. So x squared times x squared is x to the fourth. 0x times x squared is 0x to the third. And then 4 times x squared is 4x squared. Now, just like we've done in the past, we're going to subtract these two lines. X to the fourth minus x to the fourth cancels out. 5x to the third minus negative 5x to the third minus 0x to the third is negative 5x to the third. And then 10x squared minus 4x squared gives us 6x squared. Now, let's bring on down that negative 20x. So bringing on down that negative 20x, we're going to say, okay, x squared times what gives us that negative 5x to the third? Well, that's negative 5x. So we're going to multiply this whole thing by negative 5x. So x squared times negative 5x is negative 5x to the third. 0x times 5x, negative 5x is 0x squared. And then 4 times negative 5x is negative 20x. And when we subtract these two lines, we end up with, well, negative 5x to the third, sorry, negative 5x to the third minus negative 5x to the third is 0. 6x squared minus 0x squared, it gives us 6x squared. And then negative 20x minus negative 20x gives us 0x. I'm going to include that because we don't want to forget about that blank spot. And now we're going to bring down that 24. So now we're going to repeat ourselves. X squared times what gives us 6x squared? That's plus 6. So we're going to take this whole thing, multiply, that's a bad arrow, multiply by 6, and we end up with 6x squared. 0x times 6 is still 0x, and then 4 times 6 is 24. And we're going to subtract these two lines, and we get a grand total of 0, which is good because then it truly is a factor. So we're left with, after we factor out x squared plus 4, we're left with x squared minus 5x plus 6. Now, folks, that we can factor more by hand. So in order to factor that by hand, well, I'm actually going to break this down a little bit. X squared plus 4, we talked about this a little bit the other day. That was x minus 2i times x plus 2i. We really originally had that from our factors. X squared minus 5x plus 6. That's factorable into be thinking about the x plus blank format. X times, or what times what, gives us positive 6 and adds to negative 5. That'd be negative 2 and negative 3. So now we can find all four zeros. These are the ones that we already knew. X equals 2i, x equals negative 2i, and then these we end up with x equals 2 and x equals 3. So we have 4 different zeros, 2 of which are real, 2 of which are complex.